Docker logs and troubleshooting. Containers sometimes fail unexpectedly. Troubleshooting is a critical Docker skill. Logs provide valuable information about failures. Docker includes powerful debugging tools. Lesson objectives. Understand troubleshooting fundamentals. Learn how to use Docker logs. Investigate container failures. Diagnose networking and resource issues. Follow a structured troubleshooting process. Why troubleshooting matters. Even well-designed systems experience configuration errors, application bugs, resource problems, network failures, deployment issues. Troubleshooting minimizes downtime. Understanding container failures. Common causes. Missing environment variables. Incorrect configurations. Application errors. Database connectivity problems. Port conflicts. Identifying root causes is essential. What are logs? Logs record. Startup events. Application activity. Warnings. Errors. System messages. Logs are often the first place to investigate. Viewing container logs. Command. Docker logs web app. Displays application output generated by the container. Why logs are important. Application failure. Check logs. Identify error. Apply fix. Restore service. Logs accelerate troubleshooting. Real-world example. Application not starting. Docker logs web app. Database connection failed. Investigate database. Logs reveal the problem quickly. Following logs in real time. Command. Docker logs F web app. Benefits. Live monitoring. Immediate feedback. Useful during testing. Viewing recent log entries. Command. Docker logs tail 50 web app. Displays only the most recent entries. Useful for busy applications. Adding timestamps. Command. Docker logs T web app. Benefits. Event tracking. Timeline analysis. Easier correlation. Checking container status. Command. Docker PS. Displays. Running containers. Status information. Port mappings. First step in many investigations. Viewing all containers. Command. Docker PSA. Shows. Running containers. Stopped containers. Failed containers. Useful when containers exit unexpectedly. Inspecting container details. Command. Docker inspect web app. Provides. Configuration. Networking. Environment variables. Storage information. Why Docker inspect matters. Inspect helps verify. Container settings. Network configuration. Mounted volumes. Runtime parameters. Excellent for deeper investigations. Understanding exit codes. Common examples. 0 equals success. 1 equals general error. 137 equals container killed. Exit codes help identify failure causes. Common problem, container exits immediately. Docker run Ubuntu. Container starts. Container stops. Reason. No long-running process exists. Common problem, port conflicts. Example. Docker run P80:18 jinx. Error. Port already allocated. Solution. Use another port or stop the conflicting service. Common problem, missing environment variables. Applications often require DB_host, DB_password, API_key. Missing values frequently cause startup failures. Common problem, database connection failures. Application. Database unavailable. Connection errors. Application failure. Verify dependent services are running. Troubleshooting networking issues. Check. Service names. Container connectivity. Port exposure. Network configuration. Many failures involve networking. Testing connectivity with Docker exec. Command. Docker exec at web app sh. Provides shell access inside a running container. Benefits of Docker exec. Inside the container you can inspect files, run commands, verify configurations, test connectivity, resource-related failures, possible causes, high CPU usage, memory exhaustion, storage limitations. Monitoring helps identify resource problems. Using Docker stats. Command. Docker stats. Displays. CPU usage. Memory usage. Network activity. Useful for performance troubleshooting. Docker events. Command. Docker events. Tracks. Container start. Container stop. Network events. Volume events. Provides operational visibility. Understanding restart loops. Container starts. Container crashes. Restart policy triggers. Container restarts. Crash again. Logs often reveal the root cause. Troubleshooting Docker Compose. Useful commands. Docker Compose PS. Docker Compose logs. Docker Compose logs backend. Centralized troubleshooting for multi-container apps. Read error messages carefully. Common mistakes. Ignoring warnings. Skipping stack traces. Guessing instead of investigating. Logs often contain the answer. Structured troubleshooting process. 1. Identify symptoms. 2. Check status. 3. Review logs. 4. Inspect configuration. 5. Verify dependencies. 6. Test solution. Real-world investigation example. Web application down. Check container status. Review logs. Database error found. Start database. Application restored. Common beginner mistakes. Ignoring logs. Repeatedly restarting containers. Making multiple changes at once. Skipping root cause analysis. Docker troubleshooting best practices. Check logs first. Verify container status. Inspect configuration. Monitor resources. Troubleshoot systematically. Document findings. Benefits of good troubleshooting. Faster problem resolution. Reduced downtime. Improved reliability. Better operational confidence. Essential troubleshooting commands. Docker logs. Docker PS. Docker PSA. Docker inspect. Docker exec. Docker stats. Docker compose logs. Interview question. Question. What is typically the first command you should use when investigating a failing Docker container? Answer. Docker logs is usually the first troubleshooting command because it provides direct insight into errors, warnings, and startup issues. Key takeaways and lesson summary. Logs are the primary troubleshooting tool. Docker provides powerful diagnostic commands. Inspect and stats help investigate issues. Many problems involve configuration or networking. A structured troubleshooting process improves success. Troubleshooting is a critical production skill.